This video is brought to you by SRTI Park Studio, a whole new visual experience to promote your business.
Hello everyone, welcome to the Sharjah Research and Technology and Innovation Park presentation, your regional gateway for innovation and business growth. The Sharjah Research and Technology Park is a brainchild of the UAE leadership of enforcing the role of innovation and knowledge economy in developing the economy of this country and creating new opportunities for private sector, public sectors, and entrepreneurs. It's a reflection of the leadership strategy of innovation 2020-30 for the United Arab Emirates. We are delighted and lucky in Sharjah to have the ruler of Sharjah, His Highness Sheikh Dr. Sultan bin Mohammed Al-Qasimi, as the chairman of the Sharjah Research and Technology Park. His Highness' commitment to education is massive. He invests not only monetary resources in developing the infrastructure of Sharjah when it comes to innovation and education, but his dedication is immense to developing the whole ecosystem of education and knowledge economy in Sharjah. We at the Sharjah Research and Technology Park focus on four main objectives. The first objective is to develop an innovation ecosystem, not only based on the infrastructure of building and the street, but also the mindset of people. We also aim at developing next generation scientists, entrepreneurs, and leaders that can support our drive toward innovation. Our third objective is to focus on catalyzing knowledge economy, investing in technology and science and entrepreneurs so that we can have an impact and create enterprises that support the economy of the country and the economy of Sharjah and make it more competitive. And last, our fourth objective is really to invest in the future. We at the Sharjah Research and Technology Park, we identify companies and we vet them and we invest in these companies and we scale them up. Our objective is to create enterprises that will create economic, sustainable business. We at the Sharjah Research and Technology Park focus on 6 main subjects. The first one is water technology. The second one, production design and architecture. A third one is mobility, logistics, and smart cities. Fourth one is healthcare and digitization. And fifth one is renewable energy. And last but not least, environmental technology and circular economy. These are the 6 areas we focus on. And these are the 6 areas that we believe our colleges, our private sector have a competitive edge to grow and develop. We believe in triple helix. We work with government, private sector, academia, and non-for-profit organization to develop our ecosystem of innovation. We have launched research activities with universities, and we're trying to commercialize this research. We also engage with government in implementing best practices when it comes to artificial intelligence, blockchains. We launch sandbox with ministries, and we work with businesses as well in developing and commercializing technologies that will make them more sustained and more competitive going forward. We pride ourselves at the Sharjah Research and Technology Park to be able to attract some of the leading technologies into our park, whether we are talking about 3D construction or additive manufacturing or agriculture technologies or photovoltaic R&D centers or transport and mobility technologies or mixed realities. We pride ourselves to be part of a 47,000 students ecosystem at 22 universities and education institutions and more than 2,000 PhD holders, all in the same place within the vicinity of the technology park. Since its inception, the Sharjah Research and Technology Park managed to attract global players, regional players, and local players. We proud ourselves to work with international companies like GE, like Intel, and Nokia, for example. We work with GE on additive manufacturing. We work with Intel on solution related to educations and reskilling. And we work with Nokia, for example, on IoT labs and other things. We also have regional companies leading in additive manufacturing like Amensa. We have also mobile fueling companies like Kafu. And also we have companies in health like Nipta. We also have local startups that are thriving and really defining the way forward. Since an inception at SRTIP, we believed to have a global vision and regional mission. We believe in partnership, sustainable partnership. That's why we work with countries, with academic institutions, with science institutions, and with UN led organization as well. The objective is to develop sustainable partnership and a win-win situation for everyone. We developed the Sharjah Research and Technology Park based on best practices. In its start, we managed to benchmark Sharjah against 9 other cities around the world, from Boston to Marseille to Shenzhen to Bangalore to Hyderabad to Philadelphia. We looked at 6 main innovation criteria like market and investment, inter-firm activity, knowledge and R&D, human skills, infrastructure. And we looked at these things and we benchmarked with other nations around us to see where Sharjah is vis-a-vis this nation and learn from these activities as we go on. Here are some examples of the bright technologies that we are developing here in Sharjah. We pride ourselves to have the largest or one of the largest transport and logistics innovation center in the world. We in Sharjah developing next generation technologies that will be promoted in this region and will become an integral part of the mobility solution in the Middle East. We also pride ourselves to have significant investment and technology development in hydroponics and aquaponics and agriculture technologies. We believe that the Middle East food security insists that we develop these type of technologies, and we work hand in hand with the private sectors, with entrepreneurs, and with academias to develop these technologies here. Third, we also developing a photovoltaic R&D center. Our main is to promote renewable diversity and bring new source of sustainable diversity to the energy mix when it comes here in the park. We pride ourselves to launch Energy Innovation Hub, a regional platform to engage and attract innovations into this region and link them to the industries of energy within the region. We also pride ourselves at the Sharjah Research and Technology Park to host one of the largest makerspace in the UAE, the Sharjah Open Innovation Lab. This lab dedicated to entrepreneurs, to faculties, to companies to come and co-create and co-innovate the future of technologies at the park. We develop and promote this soil lab by engaging with different players, whether you are an investor or a company or academia. They all come and co-create and create businesses and enterprise out of this lab, which features cutting-edge technologies in textile technologies, electronics, metal, 3D technologies, and others. For SRTIP, collaboration with academia is an integral part of our work. We work with universities in the UAE and around the world. For example, the American University of Sharjah is one of our key partners, and we work with them on three main areas. One around IP and commercialization, entrepreneurship and development of science, employment and internship, and also lab exchange. We believe to have an innovation, we have to develop human capital and develop a strong link to academia and academic institutions. Here, I would like to share with you some other examples of the innovation we have here. We've managed at SRTIP in collaboration with academia and industry to create a fantastic footprint, a regional lab for construction of 3D materials. So we have today printed many houses using 3D technologies and using collaboration with education as well. Another example of what we do is we develop IP, intellectual property and commercialization of the IP, and the topic, for example, here is conductive concrete. Another example of R&D is we are developing an exoskeleton technology that can apply for healthcare sector and also apply for industry within construction as well. And we do this in collaboration with academia and in collaboration with the private sector as well. The Sharjah Research and Technology Park also thrives on developing an ecosystem. I have spoken about the Middle East Energy Innovation Hub. This is a platform to develop new innovation within the energy sector. To be able to conduct our work at SRTIP, we have developed a comprehensive ecosystem that includes events and themes like the Women in Technology, promoting circular economy, and launching various accelerators. Our flagship accelerator is the Sharjah Advanced Industry Accelerator. We pride ourselves to be a home for the Middle East North Africa Innovation Technology Transfer Summit. We would like to position Sharjah as a platform for technology innovation and technology transfer in the whole Middle East. And we work with scientists, with science institutions, academia, private sector to be able to do this. In addition to that, we run a series of events at the Sharjah Research and Technology Park. These comprise webinars, exhibition, conferences that allow businesses and partners and tenants of SRTIP to engage and grow and develop their businesses and build up strong network with investors, businesses, academia, and government. We also launched the Sharjah Angel Investor. The main aim of this Angel Investor is to create funds and make funds available for startups to come and grow out of Sharjah. We also host many delegations, international delegations, throughout the year at the Sharjah Research and Technology Park. We host a lot of webinars, and we aim to do more of these webinars to cement relationship with countries, with industries, and with different players. Sharjah Research and Technology Park also have fantastic facilities for exhibition. We host many exhibitions and conferences at the park, and we aim to continue doing that going forward. This is a summary of the Sharjah Research and Technology Park. I hope you enjoyed the presentation. We look forward to working with you. We will look forward to partner with you and grow with you. Thank you.
Hi, assalamu alaikum, good evening, and welcome to this session about Industry 4.0, opportunity challenges and opportunities. My name is Hani Khalaf. I'm the lead for Internet of Things and Digital Cities in the Middle East, Russia, Africa, and Turkey region at Dell Technologies. I'm pleased to have you today in today's session. Let's start by a quick introduction to Industry 4.0. So, the Industrial Revolution can really be characterized by 4 distinct phases. It started in the 1800s, or 1700s, sorry, with Industry 1.0, which was characterized by, using production lines, mechanical systems based on steam power. It was followed by Industry 2.0, which was characterized in the 1800s by assembly lines. And Henry Ford actually is attributed maybe to creating the first assembly line, to creating Ford cars more than 100 years ago. And in the 1900s, we saw Industry 3.0, which was characterized by using electronics and computers. And today, we are in Industry 4.0, which is really characterized by using cyber physical systems, so linking physical systems in the world with IT systems, and the usage of technologies like Internet of Things, cloud, and big data and analytics. Now, every organization today, because this industrial revolution was really driven by technology, needs to look at technology for their digital future. And we strongly believe that every organization, to be successful in their future, has to be a digital organization, needs to be powered by data, and needs to run in a multi-cloud world. Digital technology is what enables the organization to thrive. And as we saw, this industrial revolution was mainly driven by technology. Data is the fuel of the future. So the ability of a business to compete in the future will largely depend on its ability to use data and gain new insights into the business. And every business needs to look at multi-cloud in the future as the way of an operating model, simply because technology with one cloud provider or another will be needed for the business, in addition to having their own data center on-premise sometimes because of data sovereignty or security issues. So this is very important to realize that this digital is really the foundation on which this Industrial 4.0 is built on. Now, Industry 4.0 today, if we look at it, it is creating value for the businesses. And this value can be put in 4 buckets. One is operational efficiency. So being, able to produce more or to, make the waste less. Okay, this is all falls under operational efficiency. Part of this is if I can increase the number of units produced by a factory by 10%. This would be, one of the KPIs that, that can be achieved by a business or a factory. Now, although something worth mentioning here, although Industry 4.0 touches on many verticals like manufacturing and energy and transportation, most of the examples we'll talk today are in the manufacturing, but they are really readily available and applicable to many other industries. Second area where Industry 4.0 is helping businesses is risk mitigation. And this is reducing risk for the business, for the workers, So for example, using thermal imaging to detect if any machine is about to break or has overheated, or if a pipeline in an oil and gas company is about to break. Okay. Third area where Industry 4.0 helps is customer and workforce satisfaction. So this is how a business looks at their customer and how to enhance their experience. And on the other side, how to enhance the experience of their workers on the ground. So if we take the oil and gas industry, or if we can just take a factory, today you are able with a rugged tablet that is connected over Wi-Fi, where the factory is connected and covered, fully covered by Wi-Fi. You are able to access all your back-end systems, whether ERP, production monitoring, etc., from that tablet, and you are able to monitor the operation of the factory from a single pane of glass, and even take action if needed, regardless, without having to sit in the office like the old days. And the last area where we are seeing Industry 4.0 help is creating new revenue models. And as we will see here today, Industry 4.0, when integrated with the ERP systems and the ordering systems of some businesses, are enabling completely new experiences for customers. An example of this is one of the shoe companies, global shoe companies, who is able to create or manufacture the shoe to the customer as soon as it is ordered. So once the customer makes the order online, within a few hours, that shoe is manufactured. So this is lots of efficiency on the manufacturing side, but it's really a great customer experience. And this, when coupled with hyper-personalization, will be really a big revolution for many industries in the future. Now, fueling this revolution is a number of technologies. Robotics is one of them. Okay? Use of robots. Robots can perform tasks very accurately, consistently, every time. And that's why we're seeing them used in many industries. But we also talk about now cobots, which are robots that work cooperatively with humans. And we're seeing these also being implemented in factories where a robot cannot simply do the task by themselves. For example, in an automotive factory, running the wires in the dashboard of the car, and this bunch of wires, putting it, is a task that really is not, cannot be done by a robot. I remember recently when the model Tesla 3 was produced, and there was a delay in the production of Tesla 3. It was because they tried to do over automation. Okay, they tried to automate every task, and this really failed. So the future will be a combination of robots for tasks that can be 100% done by machines, and cobots where a human and a machine are working side by side, where the human is using the capabilities of the machine to do some tasks. Second technology where we're seeing a big trend is AI and ML, artificial intelligence and machine learning. And we are really just at the tip of the iceberg when it comes to the use of AI and ML. From detecting faulty units on a production line, which is something that is becoming now very common. A camera that sits over the production line, watches the units being produced, and can, using computer vision, determine if a unit is faulty and even take it out of the production line. Mobile networks, including Wi-Fi, 5G in the future, will also play a big role in this, because this network is what connects these things, these machines, and these in the factory floor or outside together. And 5G really will be a revolutionary technology that will enable this to be done ultra fast with the minimum latency. Of course, and we're seeing also new classes of network appear also for this domain, like LoRa and Sigfox and narrowband IoT, which also will play a role in this domain. Augmented reality and virtual reality are also a technology being used in Industry 4.0. An example of this is using AR and VR, so that a worker on the floor can look at the vital signs of the machine just by looking at it through their AR or VR glasses, or being able to train your workers in the field on machines with virtual reality, and even perform tasks and see the effect of these tasks. Of course, to do AI, ML, VR, and AR, you cannot really do it except that if you had powerful hardware. And this is where hardware acceleration comes in. So in today's world, we're seeing a lot of use for GPUs, VPUs, in the industry, and this is because these algorithms for AI, ML, or the processing power needed by AR and VR cannot simply run on normal machines that we have. So hardware, advancements are really driving also Industry 4.0. Energy storage, in the sense that today factories can store energy at certain times with very efficient batteries today, and use them at peak times to minimize their cost. So instead of using electricity from the grid, they can use energy, clean energy, which was produced by clean sources. It can use from batteries and minimize their energy costs. Material science, of course, is another advancement where new materials are appearing, things that did not exist before, and these are also advancing 4.0. And 3D printing, where this is actually a revolution in many aspects, where today, for example, instead of shipping a part across the world, I can 3D print that part on location where it's needed. Now, this technology is enabling a lot of use cases. So this is the technology, what we spoke about earlier. Now, this is enabling lots of use cases, and the use cases is really the application of that technology in a certain scenario. So predictive maintenance, the ability to predict if a part is about to fail, whether in a few days or in a few weeks. This is turning to be very, very important for many industries, and we'll see examples later on this. Enhanced logistics, the ability to link your fleet delivery with your production and the times of delivery of these packages or units to end customers, and having an AI algorithm really determine what is the best combination of which package should go on which truck to deliver to which customer at which time. Okay, so this is really something that is revolutionizing things. Asset management and optimization, safety and security, the use of cameras now, not just for security, but really for worker safety, for measurement, for marketing information. This is something that we're seeing all over the industry. Now, for this also to happen, for Industry 4.0, it's very important to see a convergence between operational technology and IT technology. Okay? And this intersection really is where the magic happens. Now, OT people, operation technology people, such as people on the shop floor, they care about parameters like yield, productivity, quality of production. IT people on the other side care about infrastructure, security, manageability, etc. These two domains have to come together, or these two teams have to come together in an organization for this to succeed. So this is very, very important. Now, let's talk also about edge, which is also a very important technology that is, advancing Industry 4.0. Edge simply refers to a distributed computing form where I'm taking the compute resources, instead from the core data center or the cloud, I'm bringing it next to where the system is. So, for example, connecting a rugged computer or an embedded computer next to a robotic arm, next to the arm where the arm is directly feeding data into that robotic computer. And this is enabling lots of cases, also edge, which we would not be able to do without having that compute resources in the field. Now, it is expected that in 2025, 75% of data will be produced and processed outside the data center. So imagine this, an organization having its data all produced outside the data center and has to be processed there. This requires a different class of compute and thinking about how things are done. And this is where edge computing comes in and can help in reducing costs of data that traveling back and forth to the core or to the cloud, security of the data, because I'm producing data here, I have to transfer it to the data center or to the cloud. I have to think of security. I have to think of manageability of all these endpoints and devices, IoT gateways, routers, etc., which are in the field. I have to think of how do I manage software at the edge. And there might be multiple softwares running on the edge. How do I manage all this centrally? So these are all questions related to edge computing. Now, with all this beauty of Industry 4.0, there are challenges, of course. The challenges can be really characterized into 6 areas. First one is the business case. Really connecting machines for a purpose or inserting technology for a purpose and really having an ROI, a return on investment from implementing a system. And this is one of the biggest challenges that any industry will face. Second challenge that the industry has today is skills. Finding people with the right manufacturing expertise, for example, but also with IT knowledge. So this is a gap that the industry has today. Third is technology. Having computers in the field, being able to collect data from the field and transport it requires a different class of computers and devices, which needs to be rugged, needs to be stable, run in harsh environments, needs to be managed remotely, needs to be very efficient from power consumption. In addition to this, as we'll see in the next slide, the complexity of the domain is so big that an organization might think, how do I combine all these technologies together and make sure they work? Fourth challenge is scale. It's different when you design for one factory, when the organization has factories in one country, but when an organization is global, wants to go global. Okay? So scalability, and how do I scale my system, whether with on-prem data centers, with cloud, with multi-cloud, that's also another challenge that's facing many organizations. Analytics needs to be something we think about from day one, because we need to know what data do I need to collect today for my business case. And what if I want to enhance things in the future? What data will I need in the future? So this is very important. And because of edge, where do I run my analytics? Do I really take all this data that is gathered, send it to the cloud, or do I run my analytics on the edge where data is produced, and then I can just take the result and send it back to the data center. And lastly, security and manageability. We're seeing today many attacks on systems, across the world, whether on utility companies, on nuclear plants, you name it. And this is something that is of a big concern to any organization that is implementing this technology, because simply their systems are outside the data center and not within their premise. Now, another complexity that an organization will see is the ecosystem. So from a platform perspective, from a networking perspective, from analytics perspective, sensors, cybersecurity, integration, specialized systems, AR, VR systems. So there's a complexity that comes from, as an organization, if I look at this menu here, who do I select to have a successful business case? And this is really why pre-validated designs in this domain are very, very important, because they will give you at least the base to start from a certain combination, or I call it a recipe, of pre-tested, pre-validated vendors, whether it's sensors, gateways, infrastructure, or software, to do a certain task. And it's always advisable to start with something pre-validated and then build on it. Now, let's move on and talk about some use cases now, and really how things are happening. So asset management, asset management is a very important, becoming actually almost mainstream now, where an organization, let's look at the factory, can track their assets for inventory, can know where each asset is, and most importantly, can manage or measure the utilization of that asset, which is very important, because if I have assets that I'm not utilizing, then I can get rid of them. For example, if a company has cranes, scattered all around, construction sites, it can simply tell how much that crane has been utilized. And if I can optimize and use maybe less cranes, in my inventory, in my system. Equipment effectiveness, that's something also, that has to do with being able to monitor, equipment remotely, simply by having sensors on the equipment that relay data. Instead of sending somebody physically there and having them take readings the old way, now we are able to read almost any operational parameter from a machine remotely, whether with the built-in sensors from manufacturer or by retrofitting and adding sensors on that device. Quality control, like we said, computer vision on production lines, where it can measure if a unit is good or defective. I also saw recently a very nice application of this in a tomato factory, where the tomatoes are flowing across the production line, and if the system sees a green tomato that is not ripe, it will push it out of the line, and it will only keep red tomatoes. And this is all done automatically using, computer vision and robotics. And lastly, least yield volume, which is again operational efficiency. So how do I maximize my production? Production might depend on 5 to 20 parameters. Okay, how do I use AI algorithms to generate the perfect values and maximize my production? This is also another use case being used in Industry 4.0. This is an example actually of one of our customers, which is a company in Scotland called the Weir Group. So they make these big pumps, which you can see here. And what they did is they decided that I need to monitor these pumps remotely, simply because I cannot afford. These pumps are usually installed like in very remote locations. So, instead of sending somebody to go and check on the pumps regularly or fix them once they break, they said, how about we monitor these pumps remotely, okay, using an IoT gateway, take the data, and based on our experience, predict when this pump will fail. And that's exactly what they did. you know. In addition, when there's a failure in the pump, because I'm reading the data continuously, when it fails, I know in advance what failed and what parts need to be replaced, which means I can send the technician on one trip only to go fix the pump instead of one trip to find out what happened and a second trip to fix the pump. So simply, what they did is they just put a vibration sensor. You know, this could be like one of the use cases. Okay, putting a vibration sensor on the pump, and like I said, this could be a retrofit of an old pump because it might not have the data points or the data sensors that I'm looking for. You know, and then by reading the data and reading, for example, the vibration pattern of that pump, I can really predict, you know, when it will fail. Because usually these pumps, and this is the manufacturer's knowledge, they go through these phases when they are about to fail, you know. So they will start, you know, decreasing in performance, you will start hearing noises, they will heat up, and then you will get to a failure. So the idea is, before I get even into this red zone, I want to stop things here, you know, and be able to schedule a maintenance, take the pump out of service, replace it, or fix it. And again, okay, also, you know, with Internet of Things, okay, we're able also to read data and define rules, okay, so that we can get insights. And we can combine data from different systems to get this insight, which is something that was not available before. Enabling workers, you know, also to do things from the field with rugged laptops, rugged tablets, or what we call the connected worker, also, you know, enables lots of use cases. Many of these industries today are suffering from an aging workforce. So having, you know, these devices in the field and enabling people to do it in the field enables really them to connect to a remote expert and be able to guide maybe a junior technician into the factory floor in real time. Security or thermal vision, that's something also, you know, advances in thermal cameras today. You know, we've seen thermal vision used last year, you know, a lot to detect people's temperature. But these thermal cameras have been used in factories for quite a while now, because from the thermal image of a pipe or a machine and being able to detect the temperature of that machine, I can predict failures also, you know, in this equipment. Or I can maybe detect a leak. So a leak would be visible very clearly in a thermal camera, but not in a normal camera or to the human eye. AR and VR, you know, training, development, modeling, VR testing, etc. You know, being able to live or to test the equipment, work on it, sometimes for very dangerous scenarios, which you cannot do on real production system, using augmented reality and virtual reality. And, you know, hyper personalization. Like I said, today's world is characterized by not just mass production of, you know, merchandise everywhere. You know, I don't want to buy a unit which is, you know, same as other units being produced. As a customer today, I'm expecting this unit to be personalized to me. So, like I said, today there are industries which enable you, by connecting production systems with booking systems, ERP systems, they are able to take an order from you, you know, and be able to implement it directly on the machines, okay, and change the configuration of the machines to do that, to do that order in a fly. So this is what we talk about hyper personalization, which is creating an experience, a different experience or product or service per customer. A good example of it actually we're seeing today is in the online platforms. So today, if you go online, based on your shopping history and using AI, the algorithm can predict what you might like and will start making suggestions for you for items to buy. So this is another kind of hyper personalization. Digital twin also is a very important technology or use case application in Industry 4.0, which allows us to create a digital replica of a physical world object, of a real object. So this pump here, I create a digital replica of it. I can do testing on it. I can stress it. I can increase the revolutions per minute to a certain number and see what would the effect would be on this. Of course, I do this in the digital world, not in the real world, but that will help me understand what might happen in the real world. So this is something very important and happening in manufacturing, in digital buildings, smart buildings, or even on the city levels now. This is an example of actually something we applied at Dell in our factory. So we connected some PLCs, some sensors on our production line. We collected lots of data sources and we brought them into one integrated platform. So this is the beauty or the power of combining different data sources from different systems which typically do not talk to each other to create new insights. And because of this, we were able to increase the efficiency and increase our units per labor hour by 20%. So this is something that we have done at Dell. Lastly, things I want to leave you with today is, if you are embarking in on a project, to transform your business, is, think of security, harness data, think of your data as your most valuable resource, and create partnerships, because this is really not a one-stop shop usually for one vendor. You have to have partnerships for this to work. Design for scale and make things simple. Do not hesitate to start small with a very small use case, implement it, succeed in it, and then scale it up. Thank you very much.
Good morning, good afternoon, everybody. My name is George Elmir, and I lead the industrial automation business for Schneider Electric in Middle East and Africa. It's my pleasure today to be with you to discuss the fourth industrial revolution, the challenges that arise from it, and the opportunities it creates for the industries and for our region and for the UAE. Let's start by discussing what is the fourth industrial revolution and how it is fueled. Well, definitely the first disruption that we have seen was created by digital. And digital has revolutionized the way we work together, the way we live together. If digital was a TV series, its first episode would be about connecting people to people. Internet has definitely enlarged the ability of us connecting to each other. It has shortened distance and time and enabled more and more interaction. The second episode will be about revolutionizing the way we live with our environment and the way we interact with our environment. The more we will have machines connected, the more we will be connected to the machines will be connected to each other, we will share data with the machines, and machines will share data between each other. And this is the power of IoT, where we are connecting everything around us with the capacity to aggregate a lot of data, what we will call big data. And the message here is, how do we transform this big data into insights? And this is where we're going to discuss about advanced analytics. The more we talk about data, the more we will have the ability to train machines with algorithms to make sense and create insights from these data. And this is all about predictive analytics. This is all about artificial intelligence. And this is completely disrupting the way we address our business, the way we look at our baseline. Our cost base point are different, our times are different, and our ability to drive efficiency and sustainability are growing bigger and bigger. Now, digital is great. It's aggregating data, it's creating efficiency and sustainability. But what else is it bringing? Well, it is making sure that the individual is at the center of action. It is empowering humans to make faster and better decisions by assessing and aggregating data that will enable these decisions. And this is occurring in everything around us, be it at home, be it in buildings where we are, in industries where we work, for the infrastructure, or for the city's management. And this is why we describe digital as a building block for a smart future for humanity. Now, COVID-19 has been a tragedy ongoing for the past months now, for more than a year, and it has created a big bang in terms of digital adoption. If there was a prize for the Chief Digital Officer of the Year, well, my bet is that COVID-19 wins it first. COVID-19 has changed the perception and has forced individuals, industries, and everybody out of the comfort zone, out of the resistance zone, okay, towards more adoption of digital tools for survival of businesses, for survivals of industries, and to make sure that the essential industries are up and running despite the disruption in physical presence in industries and on infrastructure. So this digital has created awareness along resilience and the ability to do everything remotely. And this has been a major milestone and accelerator in the digital technology adoption. So when you look at one area where COVID-19 has boosted adoption of digital technologies is when we talk about remote everything. What we have noticed is that our customers have been facing incredible situations. There was an incapacity in many cases to send staff or engineers on site to manage installations. They were faced by people that were suffering from the pandemic, so lack of skilled people to be present to run their processes. So we worked together to make sure that they could operate their assets remotely in a safe and reliable manner, monitoring what's happening through a unified operations center and helping operators on site through augmented reality tools. And that has been a very fast adoption since, very simply, nobody had the choice. So not having the choice was a huge accelerator for the adoption of these technologies that were already existing, being tested, but being resisted, right, as not adapted to the presence of operators. But more and more, we've been working on the capacity to work from home in the past year. For instance, on one platform, to design a common product or on a common construction project. So beyond remote everything, we have seen the importance of resilience across different domains. And we have seen how the different digital platforms have helped address the needs of grid customers, power customers, buildings, IT, and process industries. Well, we have definitely learned that collectively we are as resilient as the weakest link that we have. So we had to reinforce the electricity and the power and automation chains. And we got more and more resilient by automating and applying more analytics on the data that we collect. That is the ability to predict issues before these occurred and fix or anticipate some actions to make sure that the factory is up and running, the data center is not facing any issue due to the increase in demand on this data center, and that the grid is delivering the quality of service it needs to do. So across different domains, we've seen that the power of the digital platforms have served resilience. The power of data aggregated and translated into insight have helped several industries recover much faster and operate differently in a safe and reliable manner. Well, when we talk about Industry 4.0, we're not talking about the few years to come. Let's be realistic. The Industrial Revolution has been ongoing, and the future of industries is already here, right? Through our commitment to driving industrial automation, we are well placed to help and support industries reimagine what they can do with technology, with innovation, and with partnerships. Most importantly, we are committed to rethinking what is possible in industrial settings. And there, we believe that the next generation of efficiency, of resilience, and of sustainability in industries is happening now. We believe that the industries of the futures, the ones that will be the leaders in their fields, will need to adapt faster, to automate, and to better transform the food that we eat, the technology that we use, the products that we consume, the work that we do, and the environment we live in. So Industry 4.0 seems to be a great opportunity, but let's first discuss what are the challenges that industries face with this major revolution. Well, this pandemic has even increased the impact and the magnitude of the different challenges that the industries were facing. Well, let's be realistic. The first challenge is the limited remote oversight. Before the pandemic, more than 5.8 billion endpoints were predicted to make up the intelligent IIoT ecosystem by end of 2020. With limited travel and access, meaning limited ability to monitor processes physically, remote everything is a must. And the next generation manufacturing is required. So it is about connecting more and more and enabling not only remote monitoring, but also remote operations to make sure that we are getting and leveraging the maximum power of data for continuous process and efficient manufacturing. The second challenge that the pandemic has highlighted is the supply chain disruption. The scale of the pandemic is staggering. Well, 94% of the Fortune 1000 companies were hit by supply chain challenges. And you know what? Only 10% of the supply chains felt completely prepared to handle that disruption. So industrial businesses must become more resilient by focusing on business-specific outcomes, using technology to be agile and plan, operate in a multi-local manner. So I would like to insist on this point, right? Technology and digital are not the outcome. They are the means by which we achieve business outcomes. So the business outcomes will not change. The efficiency, the reliability, the throughput, and the sustainability outcomes are the important outcomes for the different industries. And this is what industries thrive to achieve, right? And they use for that technology and digital. So digital and technology are not the outcome that we're looking for. The third major challenge that is becoming more and more urgent, I would say, is sustainability and protecting the planet and the environment. As you know, 32% of the CO2 emissions come from industries. And industries, either directly or indirectly, have to play a major role in reducing their CO2 footprint and the global CO2 footprint by becoming more and more sustainable. And that is a major challenge for us and for the generations after us. Last but not least, all these digital tools, all these new technologies that are coming are creating a gap in the skills that we have in the market. And we are expected in the US, at least, for instance, it is estimated that more than 2.4 million jobs by 2028 will remain unfilled due to gaps in skills to fill these jobs and fulfill the tasks required by these jobs. So industries will have to look at upskilling their teams, at attracting new talents, at training a new set of skills that have an understanding of both IT and OT, right? And that can manage the challenges and the opportunities of the future for industries. Now, whenever we talk about challenges, we see a wealth of opportunities coming. And among the opportunities, we see four important ones that come through integration, supported by a main backbone. At Schneider, we believe that these four integrations will be first by integrating energy and automation. Second, digital and IIoT from endpoint to the cloud. The third integration will be along the life cycle of an asset, from design to build to operate and maintain. And the fourth integration is about scaling the business and moving from a side-by-side management to an integrated company management. And the backbone that supports these opportunities or integrations is cybersecurity, because the more we discuss about digital, the more we need to operate in a cyber-secure environment to make sure that we are able to deploy and leverage the power of technology. Let me dive very quickly on these four opportunities. And the minute we talk about integration is the minute we talk about breaking silos. So breaking the silo between energy and automation is very important, because from a pure player of energy management and automation, for us, energy and automation are two faces of the same coin. They work together. On any asset in any industry, energy is here to energize the process and ensure that the process is up and running. And automation is here to drive the process for the desired outcome. And if we want to look at energy efficiency, we would look at the impact on the process, so how automation can reduce the energy intensity required to produce the same or more outcome. So for us, both energy and automation are intertwined because they are the only way to get full efficiency and sustainability. If we want to move beyond the existing outcomes of efficiency on pure automation or pure energy efficiency, we have to look at how both are connected and how by connecting both of them, we can drive more efficiency and sustainability. So we have been talking about sustainability, but is this a buzzword or is it really the next big thing? Well, very clearly, sustainability is becoming as important as safety for industries. It's a kind of license to operate. And what industries will be looking at is to address sustainability in a coordinated and integrated and formal manner. Sustainability will be a competitiveness asset and a revenue generation asset for companies. And innovation will be centered around scenario planning and strategic analysis and go beyond the pure compliance topic on sustainability. So the reason I mention sustainability as an important element for industries is that today there is an increased awareness on the importance of sustainability. And from a consumer point of view, the consumer is looking more and more about the contribution of industries or their suppliers to reach these goals of sustainability. And moreover, even the financing bodies today are challenging companies on their sustainability strategies. So sustainability is becoming a top topic on the agenda of major CEOs and a must for several, if not all, industries. The second integration is digital and IoT from the endpoint to the cloud. And this means that we are taking all the data from the endpoint and aggregating that into the cloud. And the cloud is the ability to have a kind of common repository for all the data and breaking the silos of divisions, departments within the company by making data available for everybody. And everybody can tap into this data if this data is relevant for them and create value and drive business outcomes from this data. So businesses no longer have only one input, they have thousands of endpoints all producing data and insights. And the ability to tap into this data through the cloud is creating increased value, is creating the opportunities to have advanced analytics, to have AI algorithms that are required in order to achieve a connection between the endpoint and cloud. So one way to think about this, or one example of this integration in action, is a digital solution for operators. And in the Schneider world, we call that EcoStruxure Augmented Operator Advisor. And this solution combines contextual and local dynamic information, delivering one mobile experience for both the physical environment and the virtual objects. It improves operational efficiency with augmented reality and enables operators to superimpose current data, links to documentations and virtual objects onto a cabinet, machine, or plant via their tablet's camera. So the minute you have your camera on your asset, you are able to extract all the documentation, you are able to access all the data that is related to this, look into the spare parts, and improve the decision making that you need to address on fixing the issue. Let me tap into the third integration. And the third integration is about breaking or connecting, I would say, the two words of CapEx and OpEx, or if you want, connecting the words of design and build and the words of operate and maintain. The minute we talk about connecting these words is the minute that we become aware that the most optimized CapEx does not yield the most optimized OpEx. And the way industries will look at their profitability is on a TOTEX basis, which is the sum of their CapEx and OpEx. So how do we build with the most optimized CapEx and assets where the operations cost will be optimal? How do we design from the beginning a digital asset that will be serviceable in an efficient manner? And this is the name of the game here. By connecting the words of design and build and the word of operate and maintain, we are bringing increased productivity and efficiency to the assets. So if you look at this from a pure software or connected products or edge control point of view, you will see that it's not only a matter of costing and scheduling, it's not only a matter of digital services that you can drive, but it's a matter of a holistic view of your asset from design to operations and maintenance. It is about looking at the whole life cycle and ensuring that the industries have the tools, have the softwares, have the people that can drive efficiency along the life cycle of an asset. And another way to, or another buzzword to mention here is looking at the digital twin, so the digital representation of your asset from conception to operation and maintenance. And having a holistic view of this enables not only digitization, but enables process optimization and productivity of the business. This can only be achieved by breaking or changing some perceptions in the market. The way automation has been ongoing today is by defining some proprietary environments. And the more we move forward, the more we see the pressing need of having universal automation. That is software-centric. What is more important today? Is it your Apple device or the iOS that runs it? So what we want to move from is a hardware-centric automation to a software-centric automation that relies on a software and that enables industries to unleash the full capacity of upgrading their existing installation, of changing, of adapting, and creating agility and productivity for their businesses. So the more we move forward, the more we're going to look at automation from another window, from a window where software is at the center and core to the development, and where hardware only serves the purpose of enabling automation that is designed across the operating system, and the operating system is the software. The fourth integration is one that is quite important, I would say, and where we've seen some massive and interesting examples in the world, but in particular in the UAE. It is about moving from a site-by-site management to an integrated company management. And in my humble opinion, most companies in the world are managed side by side, and most of these sites are already connected. So it's about leveraging these connections and have a holistic view at the overall performance of a company, not a site, because the optimum cost point or the optimum value point for a company, okay, can be at a different optimum of the different sites. So one important example is what ADNOC has been able to build over the past years with the Panorama Command Center, where they have a holistic view of all their sites, of all their assets, and they are leveraging the power of this visibility. They are leveraging the power of data. They are leveraging the power of scheduling, of AI, of planning, to improve the way they operate, to increase their agility, and this has enabled them to have a better outcome and resist and be more resilient during the pandemic compared to previous crises. And I invite you to search and to look at what ADNOC has done with the Panorama Command Center, because that is at the forefront of an integrated company management and digital transformation. So looking at this is about digitizing the company. So the first step is making sure that your assets are connected, making sure that you are able to benchmark your operations, to benchmark your site, and increase the competitiveness and efficiency of your company. We envision that industries can look or can benefit of having this visibility and control across their sites from a single pane of glass that will enable them to identify potential value leaks or potential corrections that they need to make on their operations to drive more efficient outcomes. Last but not least, all the discussion about the Industrial Revolution, about the opportunities that it gives for individuals, industries to create more value would not exist if cybersecurity is not ensured. And the more we leverage internet, the more objects we have connected, the more we are confronted to cyber attacks. And the way we need to address this is by ensuring trust in the digital ecosystem. And this is where Schneider works in a very detailed manner across the value chain. Across the value chain of products, because cybersecurity comes from design in the products and the solution and the software. But we also have to look at how the system as a whole is deployed. We have to leverage partnership because it's not a one player task. And then we have to make sure that these solutions are maintained and upgraded to address the ever-changing risks in the digital environment. With that, I come to an end of this discussion around Industry 4.0, its challenges and opportunities. I look forward for future interactions around this topic, and thank you for taking the time to listening to that discussion.